Lectures. So today lecture is kinetic theory of gases. So in this lesson we will study what is kinetic theory gases, what are the postulates of this theory of gases. What is kinetic theory? So actually kinetic means motion. So this is the meaning of motions, and this theory actually explains the behavior of gases based on the idea that the gas consists of rapidly moving atoms or molecules. All these atoms and molecules, they move in a rapid and random motion. Rapid and random motion means they are moving in a very fastly, they are moving fastly in random directions. So the directions are not fixed. They can move x direction, y direction, z direction, any direction they can move. So these atoms or molecules can move in any directions. So we are studying their behavior. So behavior of gases means how is their characteristics like pressure, volume, temperature changes due to motions. Like these gas particles, atoms and molecules, when they hit on the wall of the container, so on hitting the wall of the containers, what happens? Pressure increases. So these particles have some volume also. So they have some vibrations. Vibrations means we can see here a gas can have vibratory or oscillatory motion. Vibratory means so it will, suppose this is the particle of the gas, so it can vibrate like this one. So this is the vibrations, or you can say this is oscillatory motions. It can also move in a linear motion. So this is one place, so it can move into other place. So this is a linear motion. So this point is one place, so it is moving. So this point is this is another place. This is moving a straight line, and this straight line is a linear motion. So if molecules have more than 3 atoms, so this is for 1 atoms, 2 atoms. So 1 atom, it is suppose the monoatomic, it will having a linear motion. It will having suppose 3 atoms like ammonia. Ammonia have 4 atoms, so it can move. It can oscillate also. During oscillation, it can, like this one, it's going to move. During its oscillation, this can also move in a linear path also, straight direction, and also it can rotate. So during moving, it has 3 type of motions. One is oscillatory, one is linear, or you can say translational, and third is rotational. It is also rotating, it is also moving a straight line, and also it is oscillating. So 3 type of motions existing in the gaseous molecule ammonia together. So this is some behavior of the atoms due to which this theory has been proposed or assumed. So for this assumption, there are so many scientists which given this assumption. So let us see what are those assumptions given by scientists. So this assumption is called as assumptions of kinetic theory of gases. So here I have divided this theory into 3 different groups for understanding the conjunctions. So assumptions. So first is your concept particle. Concept particle means all gases are made up of large number of teeny particles or molecules. So all gases, whether they are so monatomic, diatomic, polyatomic, whatever they are made up of small particles. They have identical in size, shape and mass. So in shape, all molecules, they have identical in size. You suppose you take helium, so the helium have same size. You take oxygen, all the oxygen molecules have same size. You take ammonia, all ammonia have a same size, same shape and same mass. So this is the one conditions which was assumed by the scientist. Or you can say they are having hard, smooth, elastic spheres. So they are sphericals, they are hard spheres. So this is hard spheres, like you can draw a diagram, make a small ball, they are moving in other. So they have all identical size. You keep in this mind, they have identical in size. Next, actual volume of the gas molecules is negligible in comparison to the volume occupied by the gas molecule. So they have no fixed volume. So volume of these gas molecules are negligible. We cannot compare it. Size we can compare it, but volume we cannot compare it. Now concept of molecular state. So in molecular state, all gas molecules are always in random motion. So they are moving in random motion in a straight line. Thing is that they are moving in straight line. they move in all possible directions, definitely. So they are moving in a straight line, but a straight line not this direction. They can move this direction, any means any. They are moving in space. Space means all directions, we can shortly say, and changes after intermolecular collision with the container, wall of the container. So on heating the wall or heating the after intermolecular collision, so this is the suppose two particles, there's a two particle is moving, so they can hit together, so they can also hit to the wall. So on hitting the wall, whatever the direction changes, so this is called intermolecular collisions. Molecular motion is governed by the classical mechanics, that is Newton's second law. So we can find this motion through this Newton's second law. We know, I think you know very well what is Newton's second law. Molecular collisions are perfectly elastic and there is no loss in energy during collision. So after collision there is no loss of energy, they are perfectly elastic collisions. So you know very well what is perfectly elastic. So energy before the collision, energy after the collision is always equal, that is this one. So this is called perfect elastic. So when these two suppose two gases molecules collide each other, so energy can be transferred from one gas molecule to another gas molecule. If one gas molecule has 6 joules, they will be completely 6 joules to another molecule. So this is called no loss in energy. So however, this energy distributed among the molecules during collisions, but the average kinetic energy of the molecules does not change with time as long as temperature remains constant. So thus during collision, root mean square velocity remains constant. So this velocity has given new name, that is called root mean square velocity. So there are so many molecules, so if they collide each other, so whatever energy is distributed among the molecules. So total energy of the molecules moving in the container, suppose x number of molecules are moving in the container, so all energy of all these molecules is called as a average kinetic energy molecule. That depends on the temperature. So if the temperature of the whole container inside the container is constant, then the kinetic energy of the molecules will be also constant, average kinetic energy. Suppose there in a container contains suppose 100 molecules, so average energy of this kinetic energy of this 100 molecules will be constant till temperature constant. If temperature changes, then their energy can also change, otherwise the energy will be remain same. So but 100 molecules which is inside the containers, their velocity may be different. But average energy of all the these molecules will be always same. So this is very important point, keep in this mind. This is very important thing. The individual molecules are relatively far apart from one another and exert very little or negligible intermolecular force of attraction between gas molecules. So these molecules, they attract very less. So between their force of between these molecules, they have less force of attraction. This is the molecule, this is molecule. So they do not attract each other. The intermolecular force of attraction is very less. So they always far away from each other. Effect of gravity on the molecules is negligible, as they are very small. So gravity also not play on the role, so they can move anywhere. So this is also important laws, assumptions. So kinetic energy of the molecules is directly proportional to the absolute temperature of the gas. So already we discussed that the kinetic energy of the molecules is proportional to the absolute temperature. So this is a diagram, so we can see here. So this is a average kinetic energy of the molecule of different gases are equal. I have just discussed. So they are molecules, suppose hydrogen, helium. If you take two container, or you take in one container, four gases molecules are there: hydrogen, helium, CO2, SO2. Okay. So if the kinetic energy is constant, means if the atoms having a lighter gas, maybe they have higher energy. But if the molecules are CO2, so they are the heavier gas molecules, temperature of the container is same, then they will have a lower speed. So this is also meaning if you are taking more than different type of gas molecules, they have a higher speed, they have a lower speed. If you take same type of molecules, then the average kinetic energy of all the molecules will be individual molecules may be different, but average of the energy inside the container will always same. So they can transfer energy to each other. Like this is molecules, suppose here only helium contains. So energy will same, then the here velocity of all the helium molecules will be same, different. Like V1, V2, V3, so they are different single molecules. But if you include helium also, then speed of helium will be also different, hydrogen will be also different. So it depends on the mass. So absolute temperature of the gas is actually the measure of its average kinetic energy. Now see concept of pressure. So in concept of pressure, gaseous molecules, they exert pressure on walls of the container, and due to continuous collisions between the gaseous molecules and walls of the container, so pressure happens in the container. So pressure only increases, decreases due to the collisions or increase of temperature. Validity of the kinetic theory. So how this kinetic theory is valid? So we will see here, gases can be compressible due to their small volume. So we know always if gas has no definite volume, we can compress gases till it becomes smaller. So why space? This means that distance between volume between the space between the gases is very, very large, so we can easily compress them, not like unlike solid and liquid. Compressed gas spontaneously expands to occupy whole space accessible to it, which proves the absence of intermolecular force by attraction. So this point is also very true regarding the gases. So kinetic theory, we can say it is true, or assumptions are true. Random, disorderly, zigzag motion of the molecules give rise to what we call molecular chaos. So molecules are moving in any direction, zigzag motion. So we can say these molecules have a chaos motion. When a gas is filled with air and is inverted upon the jar containing bromine vapors, so bromine vapors is colored. The color of the bromine vapors is reddish brown. So it rises up, and it proves that the negligible effect of gravity. Though it is we know that the bromine is almost 6 times heavier than air. It is 6 times heavier than air, but when you fill inside the jar, so this vapor will go up. Why it is going up? Because this vapor is not having a effect of gravity. So this we can say gaseous molecules not having a effect of gravity.